scientists have widely reported that they have found the Higgs boson using the Large Hadron Collider at CERN. What precisely did they find with this very expensive machine?
A very tiny signal obtained by much filtering and data selection. But 99% of this so-called experiment consists of an arbitrary interpretation of a theoretical model just to justify the huge amount, the huge efforts. But it has nothing to do with fundamental physics.
It has been claimed by particle physicists that the Higgs was the last missing piece of the standard model. What do we have satisfactory picture of reality now?
No, it's far from a satisfactory picture because nature is not that complicated. And none of the great riddles of physics that bothered Einstein, Dirac, Schrödinger have been solved. They would have considered this discovery ridiculous.
Why is nobody able to replicate the experiments of the particle physicists at the Large Hadron Collider in order to confirm or refute their claims for discovery of the Higgs boson?
Well, I think this is the real scandal in the 21st century because the data is not public and it has to become transparent and not because anybody is manipulating, just because nobody oversees the experiment. It's too complicated. So what we need is open data, the raw data, plus all the computer code on the internet, and that has to become transparent and accessible.
Hello everybody, I'm very pleased to be here. My talk is about the Higgs fake, how particle physicists fooled the Nobel Committee, and in a second part, maybe there's a way for science to get out of this nightmare, because I think physics is in a real crisis. But let's see what happened. What happened was this discovery of the century. Last year's Nobel Prize has been handed out for the discovery of the Higgs, and it was soon declared the most important discovery in modern times. And here are scientists celebrating. I liked one newspaper comment that said, "The simple fact that scientists mob together in agreement warrants caution and modesty." And despite the obvious lack of modesty, I think to call it the discovery of the century is a preposterous claim. And anyone who has read a biography of Einstein, of Dirac, of Schrödinger, knows that they would have considered the discovery of the Higgs boson ridiculous, because they would never have believed such a complicated model of reality to reflect anything fundamental. I'm going to argue that particle physics, as practiced since 1930, is a futile enterprise in its entirety. This seems like a bold claim, but I'm not making this up. I would invite you to read the book Constructing Quarks by Andrew Pickering. He's a particle physicist, excellent particle physicist, describes in detail all what happened in the 60s and 70s and 80s. And he noticed so much crazy things in particle physics that he became a sociologist. And he now says, okay, that's what happens when humans try to do science. But I cannot take the detached view of a science historian, because it annoys me too much to see another generation of young scientists deterred by a dumb, messy patchwork called the standard model of particle physics that hides the problems physics ought to deal with. So I shall be outspoken in my talk, and I try to give you a list of the seven deadly sins of particle physics. I think each of them is a deadly sin, but okay, there are several deaths. This is the book by Andrew Pickering. First deadly sin, overwhelming complication. the number of freely adjustable parameters in the standard model is ridiculously high. And good physics is simple. It's not that I like personal simplicity. I think in history we have evidence that the true progress in physics was always related to a simplification. It was Maxwell's electrodynamics that unified the electric and the magnetic constant and the speed of light into one formula, eliminate one constant of nature. So revolutionary progress in physics is making less fundamental constants, to have less parameters. That's what did also quantum mechanics, when it related several phenomena to the Planck's constant H. It appears in 5 different places. The biggest accomplishment of quantum mechanics is a simplification. And so it was Newtonian physics. Dozens of parameters of the solar system were condensed into one gravitational constant. And this was the true progress, a simplification. Enrico Fermi, if I could remember all these names, I would have become a botanist. Even more sophisticated picture. This is the standard model of reality. Isn't it simple? Isn't it convincing? Imagine an extraterrestrial civilization. Wouldn't they say immediately, that does not make sense? If the Lord Almighty had asked me before embarking creation, I should have recommended something simpler. This was King Alfonso of Castilla when he first encountered the epicycles in the library of Toledo. And of course he was talking about one of the greatest eras of physics, when physics stalled for several centuries with the geocentric model of cosmology. And I think we are pretty much in a similar situation today. And I think his methodology is really okay. Einstein said, I don't believe that there is any arbitrary number in nature. That means that we don't have understood yet. I cannot imagine a theory containing a number which could have been chosen by the Creator just in another way. And we have dozens of numbers. We have 17 parameters, and if you count the masses, we have 50, 60 parameters. They don't even count anymore, so many parameters in particle physics. Correct theories of physics are perfect things, and a replacement theory must be a new perfect thing, not an imperfection added onto an old perfect thing. This is the essence of a revolution, the replacement of the old with the new, not the adding of more crap onto the old. This is Richard Feynman. And now, if you talk to particle physics, they tell you in all seriousness, no, wait. The standard model is a tremendous simplification. It's so beautiful, because in the 60s we had much more parameter. Yeah, okay, but I mean, sorry, who told you? Who ever believed that these many parameters had a fundamental meaning? It was only a simplification because in the 1960s a nonsensical production of so-called elementary particles had taken place. And okay, they had 250 parameters and managed to reduce it to 50. But it's a progress like 2 steps backwards and 1 step forward. That's what's called progress in particle physics, and I don't think that's real progress. For mathematical equations, there are 2 possibilities. Either they are correct or wrong. For models, there's a third one, namely correct but irrelevant. And we're always talking about models in physics. Models have no place in fundamental physics. Well, some people are happy, okay, we work on the model, we're developing new parameters, an extra parameter, and these kind of scientists, they seem to be happy in kind of a botanic garden, saying, oh, how nice, another thing. And well, we're collecting new data. Maybe a new theory, new clues for a new theory will eventually show up someday. Why not? I think this is the strategy of a mountain hiker descending deeper and deeper in a gorge, and saying, okay, it might be I come out right on top of a mountain suddenly with a panoramic view on the theory of everything. Or to put it in words of the comedian Will Rogers, if stupidity got us into this mess, why can't it get us out? That was the first deadly sin. Second deadly sin, I think even more irritating. Particle physics glosses over the real problems that have bothered the founding fathers of physics 1 century ago. None of these great riddles have been solved. And I'm going to talk about some of the problems very briefly. Accelerated charges radiate, we know that, but there is no formula whatsoever that calculates this radiation precisely. It just doesn't exist. And look at this. I mean, modern experiments of particle colliders, we are producing the highest, strongest accelerations, negative accelerations, at the moment of the collisions, but we just don't have a theory how to calculate the radiation. There is no theory predicting how many photons, how many light would come out of that. We're just patching with models. So the deeper reason is that classical electrodynamics is inconsistent. If you have a point particle, an electric field, and energy associated to it, it's a contradiction because the electron would have an infinite mass and it has a well-measurable mass, and we can't explain that. We can't explain that. The so-called solution is renormalization. This is just not sensible mathematics. Sensible mathematics involves neglecting a quantity when it turns out to be small, not neglecting it because it's infinitely great and you don't want it. That's Dirac commenting on renormalization. Just another one of the big problems. Nobody can explain the proton mass. Nobody can explain the mass ratios. And please don't tell me that the Higgs mechanism or the Higgs fields says anything about the origin of mass. Okay? We don't understand this number, but we understand now that the proton couples 1836 times stronger to the Higgs field than the electron. I don't think this is a big progress. I don't think it's good for physics to have such a progress. And we want to understand another big riddle is the fine structure constant. Why is it this number? Why it's not another number? And another big riddle is why is the electric force so much stronger than the gravitational force? I think Dirac had a very, very intelligent idea about this. And if you think about the unification of gravitational physics and quantum mechanics, something that everybody calls the biggest riddle of physics, and everybody has his own solution for it. Dirac says the ratio of the gravitational to in a quantum mechanical object of the hydrogen atom. This is the number which is to be explained. I don't care about the mechanism, I don't care about the theory, come out with a number, okay? And among all the babble that has been published about the unification of gravity and quantum mechanics, Dirac's idea is the only quantitative one. Okay? Just a list of the unsolved problems, the contradictions of electrodynamics, and so on. And remember that the standard model says nothing about all these problems. And I think a theory, a model, that has nothing to say about the contradictions of electrodynamics. It has nothing to say about how to compute masses, nothing about mass ratios, nothing about lifetimes, nothing about the fine structure constant, nothing about the relation to gravity, nothing about the origin of antimatter, of spin, of radioactivity, nothing about the nature of space-time inertia. A model that has nothing to say about all these fundamental issues is crap. We have to ask the questions. What's the nature of? Not just patching and not just describing the phenomena with new numbers. How did it all came about? If you look at history, I think there is a strong indication that we are in the midst of a Kuhnian crisis. And I think a paradigm shift took place about 100 years ago when physicists stopped wondering about the true laws of nature and started describing it. That's when the search for the fundamental laws of nature turned into that high-tech sports we are practicing to this day. We just gave up the quest for understanding. I show you just a little example of a crisis. Otto Hahn is considered the discovery of of the discovery of the nuclear fission, but he was very reluctant to accept this, okay? There was a theory of, they already split the nucleus in 1934 or something, okay? And they had very confusing data, so I cannot make sense out of this data. So there must be an extra element, transuranic element with number of 93 protons, 94, 95, 96, 97. Complication, complication, complication. And the riddle one was a very simple one. It took physics 5 years, it took Otto Hahn 5 years to realize, oh, the nucleus has been split. That's it. Okay? So, what I want to say, this is a very, very easy solution. And it took 5 years. What about if the problem is more difficult? Presumably, it's much more difficult to find the true laws now. And the problem becomes very severe when one generation dies out, when all the wrong model is in the textbooks, when a new generation is educated with the wrong concepts. As a leading geologist says, if you would comply with Wegener's hypothesis of the continental drift, we would have to forget everything we have learned in the past 70 years and start from the very beginning. So this is impossible. I suspect that particle physics will get in a very similar situation. But we are now in generation 3 or 4, and I think the crisis is a deep one. Once the error is based like a foundation stone in the ground, everything is built thereupon. Nevermore it returns to light. Truth is found, if ever, in the simplicity, never in the multiplicity and confusion of things. We want to understand, we don't want just to describe. All these arguments seem somehow general, so I'm going to explain you the concrete strategy of particle physics. Yesterday's Nobel Prize is today's background. That's the way it works. Some leading particle physicists told me, oh, look, we have all these W bosons, so they're not interesting anymore. They're background today, so we're looking for the next. Yesterday's Nobel Prize is today's background. I think this is a thoroughly foolish strategy. Because if you do all this triggering, all this filtering, all this background removal, there is always a signal left. The analysis, this peak is the evidence for the Higgs boson. Okay, an excess of 2 photon in the 2-photon channel of the Atlas and CMS experiment. So, Stephen was pointing out that it's quite audacious, to put it mildly, to filter a foreground of 1,000. So what particle physics does is filtering a background of 100 billions. I think you need an example. At the Munich Oktoberfest, 7 million liters of beer were drunken, but there was 1 drop beer too much. We know that, because we know, that's what particle physicists argue, how they argue in all seriousness. No, we know what people did drink, we know how much beer accidentally spilled on the floor, so we can make precise calculations. We know that 1 drop of beer was too much in our signal. Well, the fact is that all particle physics got in an excited mood by this 1 drop of beer too much. And I think we could call that there is always a signal illusion. Let's assume for the moment, I think there is pretty much reason to suspect that there are artifacts. There are things you can't control. There are bugs in the analysis. First of all, in the computational analysis after the experiment. There could be a lot of misconceptions, a lot of things going wrong. But I cannot prove that. Who can? So for a moment, let's assume that everything, as they say, everything's under control, everything works fine, every background removal is justified, is precise, perfect. Then the whole strategy is still foolish. Because if you are making experiments with higher and higher energies, if you're producing more and more data, if you're throwing away more and more data, if you do excessive filtering, And if you're detecting tinier and tinier signals, there will always something that will remain. It's simple. And the signal, they don't predict anything. It's just, oh, well, something will be there. And then you assign an arbitrary meaning to this something. It's bizarre that these 2 extra photons are coming from a Higgs boson. I mean, you're all physicists. Everything decays to 2 photons, okay? So what's the peculiarity in this case? And they call 2 photons Higgs boson. They call W boson what is in essence a very fast electron and some energy that is missing. This is bizarre. Huh? There is no W boson, and no top quark has ever seen a detector because they don't live long enough. Because they have a lifetime of 10 to the minus 25 seconds, okay? You can't get to the detector. We're just inferring from the decay product something. And people don't realize how many theoretical assumptions have entered through the back door in this so-called experiment. As 99% is theoretical inferences, one assumption piled on top of each other. And I think the entire theoretical basis has shifted to something nonsensical. Let me tell this, okay? There is long known in physics the riddle of the beta decay. We don't know how to calculate this. We don't even know how this poor neutron, why and how it transforms into a proton. So what we did is give a name to it, isospin, a process where isospin is. Huh? Okay? We can draw an isospin axis. We don't understand the weak interaction, the strong interaction. Well, Heisenberg thought it doesn't make sense anyway, the distinction. But there is a problem with weak and strong interaction. So the failure of these 2 things getting together is called strangeness. And now they make a diagram, and one axis is isospin, another axis is strangeness. Can anybody tell me how these 2 entirely metaphoric concepts happen to be the axis of a coordinate system about on which all the reasoning about symmetry groups is based? That's what they tell you. Oh, there are beautiful symmetry groups operating on strangeness and isospin, okay? That's what Richard Feynman said. Where does it go together? Only if you add stuff that we don't know. There isn't any theory that has this symmetry group, whatever the hell that is, that we know it's right, that has any experimental check. Now these guys are all trying to put this together. They're trying to, but they haven't, okay? I think we have to go back to reason. God created everything by a number, weight, and measure. Particle physics doesn't predict any number, okay? But anyway, number, weight, and measure. Today we have bottomness, hypercharge, strangeness, isospin, and so-called particles are little packages with these labels on it. I think to call a particle just a conglomerations of these labels, I think this is a psychological displacement of how much one has distanced from reason. Because it's not a particle, it's just a package of labels. And I think any reasonable person has to have some doubts on the model, but there is one obvious good argument in favor of the standard models. That is, thousands of physicists wouldn't deal with a theoretical model of reality if it was baloney. But it's a flawed argument, and has been disproved many times in history, because in big groups there is groupthink. Think about economics. Think about how they went wrong. And I think also particle physics has become a business too big to fail. There are other interesting details about how communication, how discussion takes place in particle physics. If you talk to particle physicists, they tell you, oh no, we have so many internal discussions, it's so many people fighting against each other and so, but you never hear this, yeah? You never see that published. Yeah? Get it published. Wouldn't be, if you have a developed thought, wouldn't it be good to write it down and publish it? But you never see these dissenting opinions published. It's a streamlined culture that here. So another two other groupthink statements I'd like to challenge. The standard model is precisely tested. It's so precise, it's so wonderful. Ask 5 different people what the most precise test is. You get 5 different answers. There is no precision in particle physics because the detector has an energy resolution of 6%. This is a poor accuracy. Even if they do their best, I don't deny that, but it's a poor accuracy with respect to other fields of physics. So no precision test whatsoever will come out of particle physics. And yeah, we are doing this experiment because our next collider might discover the second, third, or SUSY Higgs variant, the lightest supersymmetric particle, of course explaining all dark matter. No galactic physicists would believe that, but anyway, yeah. Lightest supersymmetric particle, a 4th quark generation, many black holes, extra dimensions could show up, gravity in your face. That's what the string sect tells you, okay? I don't think this is science. Yeah. They predict the next collider will show something. But I would like to tell something. The real discoveries, the true revolutions in physics, sooner or later had always transformed into useful technology. There would be no cell phones working without Maxwell's theory. There would be digital cameras are whatever, but they are evidence for the quantum constant age, and the phenomenology of general relativity goes into the GPS receivers. So I would think useful technology is a sign of something works and something is correct, and that would be an independent, it could be an independent verification. But there isn't even an idea how a quark, a Higgs boson, or a W boson could be something useful, could transform into something useful. These concepts haven't proved their existence, their usefulness, their credibility outside the narrow environment of academia. And this is a problem. And by the way, I think extra dimensions, we might discover something. Particle physics has transformed into a kind of zombie science, that it's not useful anymore, but it keeps, even if it's dead, it keeps walking, kept alive by endless transfusions of cash. But it's no genuine result in there. And I think there is a lack of transparency in particle physics. Nobody can oversee the experiment. It's impossible to check it. The data should go on the internet. And I think it's ironic that you all know where the World Wide Web was discovered. At CERN, Geneva, the only place in the world which doesn't make use of the World Wide Web. There's no useful data on the internet. And when you talk to particle physics, you have to be an expert to understand the detector data. It wouldn't be useful for you. No. The laws of nature are not detector dependent, and it's your business to make it transparent, accessible, and public. And the fact there is no single collision data, no single wire chamber photography that could be useful for anybody outside the community. I think this is a scandal in the 21st century. I think we have a problem. But the problem might be even a more general one than particle physics. Look at this. This is Scientific American. It explains the true progress of physics for everybody. Yeah? Don't you understand? The extra-dimensional geometry can be very peculiar, resembling an octopus with several elongations. The energy inside the brains could provide the positive energy needed to start inflation. I also think that scientists at CERN, they know pretty well this is nonsense, okay? If you talk to them privately, they would even admit, but nobody makes a stand in public. Why? Why don't they just spell out that this is nonsense? I think because they are afraid of the collateral damage to their own ramshackle building once the string bubble deflates. And so they keep saying, okay, yeah, this is progress in science. Funding needs a pacified atmosphere, so don't touch that. But I think we are in a crisis, and sooner or later, I like Galileo. I don't feel obliged to believe that the same God who has endowed us with sense, reason, and intellect has intended us to forego their use. How can we fight this degradation of science? I don't know. To teach you to pass from a piece of disguised nonsense to obvious nonsense, this is my attention. I really like this guy, Wittgenstein. He was Austrian. Now look at this. Yeah, I'm trying to apply Wittgenstein now, okay? The horizon problem, the so-called flatness problem, I think the true reason is we don't have understood gravity yet, okay? But you can fix these problems with inflation. Suddenly this universe has inflated in its first 10 to the minus 35 seconds. Why not? Yeah? Roger Penrose says, whatever this generic structure is, it's not something we can expect to become ironed out simply because of a physics that allows inflationary processes. Sometimes Penrose was more outspoken. Inflation is a fashion. High-energy physicists visited on cosmology. Even aardvarks think their offspring are beautiful. But now immediately it turns serious science that finds its way into the news channels. A couple of weeks we heard of the BICEP collaboration. What are these guys telling us? Yes, we have found evidence for a certain signal in the cosmic microwave background, and there is a curl in this vector field, and this could only be there if there are gravitational waves. Okay, but I mean, look at this. I mean, it's quite audacious to say something about 380,000 years, because you have to remove all the background we've heard, okay? But these guys are going back in time. They're extrapolating to the very first fractions of a second. We see the gravitational waves there. And not only, then another tremendous extrapolation back to the first 10 to the minus 32 seconds. Well, this gravitational wave pattern proves inflation. Now we have evidence. I don't know. I don't know what to do. I mean, people don't think anymore. We have managed to transfer religious belief into gullibility for whatever can masquerade as science, says Nassim Taleb. And I wonder, I mean, how could this happen? I mean, how could anybody say that this is evidence? How could you dare to call it evidence? And I think the basic reason is because we are humans. Because if you're in a conference room among 500 people discussing about inflation or dark energy or quark confinement, you don't want to walk out saying, no, this is nonsense. Because it feels so terribly bad to walk out and to be alone. And I think this is maybe the real problem when we are doing science, because we are humans. Whenever humans do science, we have this problem of conformity. What could we do? We could try to learn from history, go back to the methods of science, I mean, of course, there should be falsifiable theories. I mean, I forgot to say, I'm not talking only about the fairy tale stories, like string theory, and everybody knows there is no test, so it's not science, okay? But I'm talking about the so-called experiments. If there are no experiments, it's religion. But it doesn't mean that if there is an experiment, it's healthy science. Because you have to look at the theoretical assumptions. You have to try to disentangle belief from what you think is evidence. So it should be falsifiable. And another comment I like by Popper, big science may destroy great science. This is another separate problem. And there are paradigm shifts. Scientific knowledge never increases. It does increase steadily, yeah. And once in a while we have a crash. Yeah? It's like the stock market. Yeah? You have a steady increase and crash. The bubble deflates. Why is this? Why is there this bias in time? Described by Thomas Kuhn. He said we have periods of normal science and then these revolutions. Because we are gradually establishing concepts. Huh? And it's very easy to make friends if you postulate a new particle, and your friend, if you're a theorist, your friend will investigate the particle, and if you're an experimentalist, you're happy to work on a new proposal. So Andrew Pickering called this a symbiosis of theory and experiment. That's what happens. It's easy to make friends, it's easy to establish something new, but if you try to challenge a concept, you have a lot of enemies who already work on the established concept. And Erwin Schrödinger said, okay, once there is a feeble excuse, there is no further need to ponder over it. And I think this is what we observe when we're talking about, okay, there is dark energy. Okay, there must be quarks. Okay, there must be a fourth neutrino species. Okay, there are neutrino oscillations. These are excuses. And we are just accumulating new parameters, but it's not a healthy building anymore. Nobody ever won a Nobel Prize for proving that something didn't exist or by showing that something else was wrong. That's another author I like very much, Noble Dreams. It's a very interesting book about, it's an absurd story about the discovery of the W boson. Just read this book, it's fun, but it's real evidence that something went wrong already 30 years ago, and there is no evidence that things have changed in the meantime at CERN. Peter Gallison, another book I like very much. I think these people are doing very valuable work, historians of science, who just show you that science works differently from the common narrative. And, this is in German, the Solomon Asch conformity experiment. There are nice YouTube videos on the internet, and you have people with actors, and the actors say, oh, X equals to A. 5 actors in the room say, no, it's X equals to A. So the remaining person says, okay, X is as long as A. Huh? We are humans, we tend to conformity, we like common opinions where we hesitate to disagree. And I think there is pretty much evidence that the way we are doing science today has a problem. Scientific evidence. What should we do? First of all, we need freedom. We don't need censorship. It becomes more indispensable than ever to preserve the freedom of scientific research and the freedom of initiative for the original investigators, because these freedoms have always been and will always remain the most fertile sources for the grand progress of science. That's Louis Victor de Broglie. And a second thing is, obviously something has gone wrong. Some established concepts are not reasonable. So we need to define new criteria for scientific evidence. Maybe this would be a preliminary idea of mine until we have a better system. Maybe college lab experiments, maybe open data. I looked up in the SCSS database. I believe there is a cosmological redshift. That doesn't mean I need to interpret it as an expansion, but I see that there is a cosmological redshift, and the scientific evidence could be application and technology, but not necessarily something that is established in one community, like neutrino oscillations or W bosons or whatever. The problem is, how do you form your own opinion? And the usual process is you just believe the experts, okay. But once you challenge all these concepts, once you stop parroting, I'm parroting too. I mean, you can't do all the experiments by yourself. So in a certain sense, we're dependent on parroting, okay? But once you try to stop, you're in a desperate situation. Because as an individual, it is incredibly difficult to separate, to draw the line between the undoubtable facts, so to speak, so, okay, a stone is falling to the ground, or just an established concept which might be very misguided. I'm not talking about the fantasy, the fairy tales of strings and brains, okay? This is one thing. But also to separate the so-called established facts of the standard models, it's incredibly difficult for an individual. And it's clear that once you stop parroting and use your own arguments and reasoning, you arrive also at different opinions about what the undoubtable facts are. And that's why maybe I might disagree with Stephen in some detail, or maybe Bill might disagree with me. Huh? But that's okay. I don't think that different opinions are a contagious disease. I think it's a virtue, and that's why I'm happy to be here, by the way. Huh? We must allow for these doubts. We must allow for individual checking, not just conforming to the mainstream opinion. What I would propose is a kind of falsifiability 2.0. Let's define our knowledge, the world scientific heritage. We're talking about the data, about the public data. I think they have to be complete, all the data. We have to store it permanently. We have to do a very good documentation. Every process of analyzing, every data reduction, every triggering has to be public, has to be transparent, has to be clickable maybe one day from Wikipedia. It has to be public. I should not only have the data, but also the software, the code to repeat all the computation. That would mean to be repeatable in a true sense, keep the metadata, and also provide support. Okay? This is a dream. I think we're very far from this dream, but I think this is a chance, a kind of evolution of our civilization, and sooner or later science has to take their advantage from these possibilities. What you hear is from particle physicists, oh, we do our best, but we can't handle more data. It's a tremendous amount of data. If you pile it up on top of the Alps, it would be DVDs piled on top of the Alps. We can't put this on the internet. There is just not enough disk space. Sorry. No. Sorry, but who told you to build experiments that produce way more data that anyone can reasonably analyze? Whose fault is it that collider physics has grown to a nonsensical size? And now you take this as an excuse? So let's be more humble. We have the LHC data. Too much data, okay. put the LEP data on the internet, put the DESI data on the internet, put the Tevatron data on the internet. Okay? Just go back in history until you have enough disk space. And if the old experiment is not there anymore, just rebuild it. It would cost the air conditioning bill of the CERN to rebuild a 1960 experiment. I would love to see the Gargamel data. I would love to see Ting and Richter's experiment on the internet. I would be delighted to see Lederman's neutrino experiment. I really want to see Hofstadter's collision experiments on the internet, okay? I think it's their damn business to the taxpayer to put this on the internet, to get this data on the table. I think it's their obligation to the coming generations of scientists, and I think it's their obligation to the future of science to make this data public. Thanks for your attention.